Thank you very much for having me. On behalf of IS Andes, it is my pleasure to be here with you. The idea of my presentation today is to show what the company is currently doing across the region and the world, and to focus in a project in Chile and the project in the US. We communicated this a couple months ago. So, without no further ado, we can you see my presentation on screen? Could you confirm if you see the presentation? Yes. Okay, I imagine you can. I'd like to tell you a bit about AES. It is a global company that has its headquarters in the US and Virginia. It was created in 1981. It has a presence in 14 different countries and 4 continents with more than 2.6 million utility customers. To a large, in general terms, it's a company that has more than 30 gigawatts of power in operation. To date, we manage a project portfolio of 8 gigawatts with projects that are already under construction phase in renewables. They're renewables, or they have power purchase agreements that are signed. We're around 8,500 people across the globe, and we're well known for our commitment in sustainability. Hydrogen projects for us are truly important in the decarbonization process and likewise in our growth plans due to different reasons. We have many renewable, non-conventional renewable energy projects under construction and operation in these countries. We're leaders in building and operating these projects. We have strong leadership in the storage of energy. We've created a company that's called Fluence. That's a partnership between us and Siemens. That we're doing this correctly, and we have many battery energy storage systems based on lithium systems.
En procesos de desalinización de agua.
We also have saltwater desalination experience. We have projects in Mejillones where we have different pipelines, desalination plants that are currently under operation and have been built, and we have them within the company, and we have presence in places that are key for hydrogen production. And we have a match then between energy storage, NCREs, and saltwater desalination processes, and that lets us cover much of the value chain of hydrogen production. That is why we're taking this as a significant element in our growth plans. Within the assets that IS has globally, we're present in the international business unit in the most competitive countries for producing hydrogen in the future, according to the international renewable energy projections, right? Chile, Colombia, Mexico, and Brazil are mainly seen as countries where the most competitive hydrogen will be produced from 2040 onwards, approx. If you look at the chart here, the comparison, when we're in the phase of potential competitors like China, Australia, Saudi Arabia, etc. It's prices that are more or less similar. And compared with countries that we now see as potential consumers and customers, like the European Union, Japan, Korea, the price of producing hydrogen in those countries versus the countries where AES is located, it's different. And you may see this in the example. The production of hydrogen in Korea versus the production of hydrogen in Chile, in terms of cost per kilogram, should differ at around 70%. What are we doing in these countries? We are creating pipelines. We're working on project portfolios. The idea is to have at least one project per country, and two or three, a couple of them, to maximize the probability and minimize risks. Projects have a giga scale mainly because what we look for is scale economies for the product to be competitive, for it to have for it to have a price of sales that's accessible to the end consumer, and we're aiming for projects that can operate by 2030. We put this date because we've seen that to date, and from here onwards, there's going to be a series of regulatory adjustments for these programs to be constructed. There's going to be a growth in demand. There's going to be improvement on technology for the consumption systems to be able to adopt the use of hydrogen at a medium term within the global map that was mentioned. The main producers, you can see them on screen, right? Chile, Brazil, Colombia, and the US with the main consumers. In this case, it could be the European community, right? Korea and Japan. And here we have the map with the projects that we have in AES now. We are working on gigascale project in the US. We have an initiative which I'll tell you about later. There's an initiative that will also manage of more than 1 gigawatt of renewable power in Colombia, the same in Brazil, in the state of Ceará, and the north of Chile in the region of Antofagasta. All these projects, it's their aim is to have non-conventional renewable energies, mainly wind power, solar power, battery storage system for energy management, and hydrogen production through electrolysis. Here we have a map of what we see as products of these projects, basically through renewable energy and the production, desalinated production of salt water. When we combine them in the electrolysis process, we can produce hydrogen to later transport it either through pipelines, ships, or trucks, and aim for aviation and mining and heavy-duty trucks sector, which could be local consumption in the same areas where these projects are located, or another vision we have is to have this gas-based hydrogen, which could be combined with nitrogen, obtained through air separation units and through hard wash process, generate green ammonia, which can be transported, and through a decracking process, we can come back to hydrogen to satisfy needs of the steel industry, refineries, etc. Or it could be used as green ammonia directly as a fuel system, either for ships, for large ships or vessels, and large consumption. So, in simple words, we're saying that hydrogen, for AES, hydrogen can have two types of deliverables, either hydrogen itself or green ammonia. How do we seek to achieve these goals, long-term goals we have? To operate at least one gigascale project by 2030 through a strategic approach. What we seek is to have partnerships and off-taking. First of all, off-taking, it's because these large-scale projects mean that we must have investment levels of $1 billion. We're talking about $3 or $4 billion at least. And to ensure we have that capex investment, what we want is to obtain an off-taker that one or many off-takers that are able to capture total production purchase, or most of it, most of the total production. And in second place, we hope we can have partnerships, to equity partnerships, to invest in this business, partners that have enough financial support to invest billions of dollars. And in second place, partners that have some type of knowledge on hydrogen storage, treatment of hydrogen, right, distribution of it, for them to complement to the to us knowledge regarding NCREs, batteries, and saltwater desalination processes, and to reduce the credit worthy or the credit issues we have for this investment, right? This slide is a summary of the projects we have. The project we have in Antofagasta, some of you know this. This slide was published in March 2021, and it establishes AES's initiative, which is a project in Antofagasta, was an investment of $1.5 billion to initiate operations by 2025, a green ammonia project that sought through a partnership with a company that at the time was unknown of. They sought to have a project that had an installed capacity of around 800 megawatts of renewable energy to produce around 250 annual tons of green ammonia for exporting abroad. That project is now one of the pillars of our company and the initiatives that we have in Chile. The plus 1 gigawatt project that we were mentioning before in Chile, clearly many of its characteristics have changed. And what are we currently doing? Our installed capacity we currently have is more than a gigawatt, and it's at around 1.5 gigawatts. We have already hired the engineering company who's making all the work, doing all the necessary works to create the EIA, environmental impact assessment. We have a project, it's quite an extensive project that has a large impact. That's why we're thinking about, we're studying community relationships, right? We're on site activating the shared value plans for the project to be able to add value to the place and not only have a negative impact on it. It's important for it to have a positive balance. That is why we've been working for more than 1 year with the different stakeholders neighboring to the project. They're complex, large projects that have times of construction of around 5 years, that have an environmental footprint that's large. They have extensions, thousands of hectares. That is why early work with neighboring communities and the different stakeholders is very important, which is something that we've been doing for some time now, as I said. And there's certain regulatory barriers that we're also trying to solve. Driving for this to happen, it's issues with territorial compatibility, with the need of the project of extracting energy from the grid. It's a project that's connected to the grid, and it's a self-consumption system that is enormous, and it has a production capacity of more than 1 giga and a consumption capacity of more than 1 giga. And the idea is that what is the surplus can be injected into the network, and when the project needs energy from the grid, it can take it from there too. So that's why we're negotiating the interconnection permits and everything that will let us have a rate to build condition close to 2025 to make an investment decision and to be able to put the first kilogram of hydrogen into launch it into the market before 2030, by 2030. And that was regarding the project in Chile, but I'd like to tell you about a case that's a bit more advanced that we have as a company. Is a US project that is called Felix. Project Felix, it's a company, it's a partnership with Air Products, a leading company in generation, transmission, distribution of hydrogen. This is a project that extends the leadership of AES in the sector. We've formally communicated this, and it's an investment of $4 billion. It's a project strictly of green hydrogen to produce more than 200 daily tons of this product and to supply the national market. These are the numbers. In installed capacity, this project in Texas has 1.5 gigawatts of renewable nominal power, only solar, wind and solar. As it wants to initiate commercial operation in 2027 and then 20 commercial on 2024. The partnership, AS invests 50% of the capital in our products, the other 50% of equity. And as I mentioned before, what it seeks is to supply the local industry and transport systems. It's a project that is so large that it avoids 50 million tons of carbon dioxide throughout its entire life cycle. We have global and local benefits, mainly the construction, different construction jobs. These facilities need on site staff. It's not like NCREs, which are automated and they minimize working on site, but we permanently need here hundreds of workers on site permanent staff and workers that transport the end product from the production site to the consumption site. And we're talking about thousands of jobs here. It also supplies a safe, environmentally friendly green hydrogen product, and it drives the the region's economic growth. It's important for this to be aligned with the objectives of the Energy Department, of the U.S. Energy Department, and when it operates, it will not exceed the regulations, the safety regulations of Texas, right? In terms of emissions, it does not emit pollutants. It does not have sulfur or nitrogen oxide or carbon monoxide, carbon dioxide emissions. It's very clean project. In terms of water consumption, we've sought for these cooling sims for the cooling systems not to consider the system with water, but you consume much less water, air, and the 90% of the cooling systems of the project are based on air cooling and not water cooling, and all the wastewater, the treatment of water will not contain any extra elements that was not already in water. We're not adding toxicity to environment. In terms of safety, this is a technology that is approved. I've heard much that there's certain reluctance to the use of hydrogen, a bit of fear. This company, our product, works since 1960 in the US. It has agreements with NASA. These cryogenic trucks that are used and the containers that are used for transport of hydrogen and storage of it for more than they were being used in the U.S. for more than 40 years. They have 4 tons for transport. They can use on-site storage. It's technology that's proven already, and through a partner that has been working for more than 80 years on these topics. And that is my presentation.